Assalamualaikum and greetings to the dedicated panel. My name is Fahmi bin Yusri, matrix number DE190168, an undergraduate student from Bachelor Degree Electronics Engineering. And in this video, I will present my final project, IoT-Based Energy Consumption Monitoring and Notification System for Home Appliance. The content of this video will start with the introduction of my project, problem statement, objective, scope limitation, methodology, work plan and circuit development flowchart, circuit design and project component, preliminary result for the semester and also semester wrap up. So for the project background, as you know, electricity is vital for the human in the daily use. Since it is introduced by the Thomas Edison in late 1800, and on top of that, on behalf of all residents in the United States, had electricity in the 1925 for basic home appliance. And for the modern day demand, previously the cooling system of a house was determined by how the ventilation was designed for the house, and however the rapid growth of the AC motor has resulted in the use of fans as cooling system in modern buildings. And the purpose of this project is energy monitoring. For all these appliances, is important to provide vital insight and trend that can help the user to control and conserve energy in the future. Problem statement. In general, if home appliances are not well maintained, it will contribute to the high electricity consumption. Heater, water heater, air conditioner, refrigerator and clothes dryer are the example. The electricity usage for air conditioning can be considered as high because the process of cooling and moisturizing the environment requires more energy. According to Tetsu Kubota in his paper, Energy Consumption and Air Conditioning Usage in Residential Building of Malaysia, it stated that air conditioners were owned by 65% of the general population, with the daily average usage of 6 hours per day, and the air conditioning had the highest annual power usage at 1,167 kWh per year. And one of the main reasons of air conditioner can consume too much electricity is when it runs out of refrigerant without the user knowledge. Furthermore, due to the nature of home appliance, electricity usage cannot be monitored individually. And lastly, electricity meter can only take energy reading from all appliances. Having a separate monitoring device for each home appliance and its power consumption trends is useful to the user. The objective of this project, firstly, is to develop an energy or power consumption monitoring and notification system for home appliance, to develop a dashboard for power or energy consumption monitoring using IoT platform, and lastly is to evaluate the functionality of the developer IoT-based project, as well as its ability to precisely measure the power or energy consumption of each home appliance. In order to fulfill the stated objectives, this project will be limited by the following scope. First, the data and measurement from voltage and current sensor will be collected for the home appliance and will be wired from the distribution box. No MCU ESP32 model with Wi-Fi capability will be used as a microcontroller. The Blink IoT platform will be considered in the development of a dashboard. One LCD will be placed as a physical energy consumption metering. One such application will be considered to notify the user on the real-time data of energy consumption, and also single-phase incoming power line system will be considered in the proposed IoT-based energy consumption monitoring system. As we can see on the screen, this is the block diagram of the IoT-based power energy consumption monitoring using the non-MCU ESP32 module as the microcontroller, and by using both current gram and the voltage sensor wiring from the receivable circuit breaker from the distribution box. And the IoT platform that will be considered is a Blink dashboard. And another feature that proposed for this project is the WhatsApp notification system that will notify the user. And for this semester progress, we only take the measurement for the voltage sensor and from the current sensor, and also connecting to the ESP32 module with Wi-Fi, and also go to the cloud internet for the IoT platform. And other display option is we use serial monitoring from Arduino IDE serial monitor. Next on the screen is the project work plan for track. The initial of the project will have the introduction, literature review of the related works, methodology, circuit development, hardware, software testing, and then we will, if we didn't obtain the output testing, we need to troubleshoot at the circuit development, and then we will do the hardware and software again, and then we will obtain our preliminary result. So for the circuit development, we divided by the two parts, which is first is a voltage measurement circuit, and second is the current measurement circuit. And then we will wire the circuit, and then upload the coding for the voltage measurement and also coding for the current measurement, and then we will do the troubleshooting for the hardware and also the software. And if the software can be verified from our Arduino software IDE, and then we will upload the code into the circuit, and then we will see if the coding can be run with the circuit for the both voltage measurement circuit and also current measurement circuit. And this is the main component for this project, which is first is Node MCU ESP32. This board has its own Wi-Fi module, which is functional for IoT-based application, and also ZMPT101B voltage sensor. It can monitor voltage and power up to 250 volt alternate current with high precision and good consistency. So ICT013 current sensor, and this specific current sensor can detect loads up to 50 ampere. And for the circuit design for voltage measurement, the circuit design consists of the Node MCU ESP32 and also ZMPT101B, and in this diagram we use bulb or socket for our load, and ZMPT101B is connected to the pin 35 ESP32 that have ADC capability. And the circuit design for current measurement also consists of Node MCU ESP32, SCT013 connected to pin 34 of ESP32, and we have a burden resistor circuit consists of 10 kilo ohm, 2 units of 10 kilo ohm resistor, and 1 unit of 100 ohm resistor, and also 10 microfarad capacitor. And also the load is from the bulb or socket. As we can see on the screen is a preliminary result for this semester, and we are looking at the voltage measurement monitoring result. The first figure depicts the serial monitor that we obtained from Arduino IDE software, and the second and the third is the voltage monitoring to Blink mobile apps that are with load and with no load. And also we build another dashboard for the current monitoring separately for the Blink IoT dashboard, and also it also successfully being monitored through the serial monitoring in Arduino IDE software. And throughout this semester there are a few challenges that I can highlight, which is first is a single phase line left wire cannot be obtained from the RCCB, and then the RMS reading appear to be unbalanced, and the latest version of Blink cannot be debugged and connected with ESP32. So for now and for this semester, I using the Blink Legacy, which is the very first edition of the Blink IoT platform. As a conclusion, for this semester, the very first step for the IoT-based energy consumption monitoring and notification system has been developed. Moreover, for energy monitoring, Voltage and current measurement is vital in order to obtain other parameters for energy monitoring, and then also the measurement then can be monitored through serial monitoring and Blink mobile apps dashboard also been developed in this semester. So for the future work for FYP2, the upcoming project development process will be focusing on the development of home distribution box and also a controller box. The serial monitoring will be replaced with LCD monitor at the controller box. The firm and reliable IoT cloud platform will be implemented for a user-friendly dashboard. And lastly, to integrate the energy monitoring with push notification system that using WhatsApp social media platform. And that's all from me for this presentation. Thank you for your time. Thank you.